In this video, we're going to talk about electron configurations of ions. To this point, we've been doing neutral atoms, but ions really aren't any different. We just have to make sure we have the correct number of electrons. So when we're doing ions, for anions, so ions that have a negative charge, for every negative charge we have, we add one additional electron. For cations, for positively charged ions, for every positive charge, we take away an electron. And then the only thing that can be a little bit tricky about ions is when we're dealing with transition metals. So for transition metal ions, we actually lose the highest s electrons first, and then we start losing the d's. And I won't give any examples involving inner transition metals. So let's look at a couple examples. All right, so if we want to draw the electron configuration for O2 minus, what I typically do is find the element whose ion I'm trying to write the electron configuration for, and then just move the number of places to the left or the right depending on whether I'm a negative or a positive charge. So in this case it's O2 minus, so I need to add 2 electrons. So essentially I'm writing the electron configuration for 2 boxes to the right. So the electron configuration for O2 minus is the same as the electron configuration for neon. So my electron configuration would be 1s2, 2s2, 2p6. All right, now we have strontium 2+. So, right here's strontium. And so if I want to write the electron configuration for strontium 2+, take away 2 electrons. And so I'm going from element number 38 to number 36. So when I write the electron configuration for strontium 2+, I'm essentially writing the electron configuration for krypton. So for krypton, right, we're going to have the 1s, 2s, 2p, 3s, 3p, 4s, then the 3ds, then it's going to be 4p, and we're in the 6th column, so we'll end with 4p6. So that would be the electron configuration for strontium 2+. All right, finally, let's look at a transition metal. So in this case, we have titanium, and it's titanium 3+. And so maybe the easiest thing to do for transition metals, because it's not as easy as just how many spaces do I move over for the transition metals, because I'm going to lose the s's before the highest s's before I lose any d's. So what I would typically do is draw the electron configuration for titanium, and then draw the electron configuration for titanium 3+. So for titanium, I'm going to go to the 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. So neutral titanium is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d2. And now for titanium 3+, I'm going to lose 3 electrons, and I'm going to lose the 2 4s electrons first, and then for the third one I'll lose 1 of the d's. So then for titanium 3+, it'll start out the same. And I lose the 2 4s's and 1 of the d's, and so I'll finish with 3d1. And that would be the electron configuration for titanium 3+.